one thing I think a lot of people who are working in this space um, are trying to understand is what exactly are the embedding models? Like what is the data that they're sort of distributing around that really identifies these, I guess, these open source or sort of these public APIs. So what are you importing when you're playing with that? What exactly is that?
So, I mean, typically the models, I guess the more recent ones, I mean, there are historical ones like Word to Vec, but I guess the more modern ones now, they're typically encoder models. Um, so there's three broad. Again, you can use something like T5, which is an encoder decoder, right? There's always caveats here, but there's three broad like classifications of transformers, and they're all kind of unfortunate because even though we're going to call a model an encoder, like an encoder only, it does have a decoder. And then you have the encoder decoder models, and then you have the decoder only models, right? So the encoder only models are typically like your BERTs. Your encoder decoder models would be like your T5s. So Google released a model called T5 several years ago. Also like UL2 is another one. And then the decoder only models are like kind of like the stars of the show right now. These are your, GPT-3s, GPT-2, Palm. Those are kind of like your decoder only models. Now, typically, and they're caveats, but typically when we're using an embedding model, we're using like an encoder only model. And so you have basically an auto-regressive encoder, and then you get a nice vector space as your output, and then you're able to use that for something. Uh,
What does OpenAI need it? So is this just a label to the way they do it, and maybe they have different algorithms to do the encoding, or
no, so the reason that it's kind of like these are just the terms that have kind of evolved over time. There's actually a really nice like a really nice paper that has like a historical tree. Actually, it might even be a GitHub repository. I'd have to go double check. But it has like a very nice tree of like this is the lineage of like the large language models, and so it shows you the three different branches. I think even Jan LeCun kind of criticized the naming convention. So Jan LeCun for folks is like one of the heads of AI, if not the chief AI scientist at Meta, and he's a key player in the space, a key thought leader. And he even was like, yeah, it's kind of unfortunate how we've named this because the naming is kind of confusing. And like, even though it says it's only an encoder model, there really is a decoder there. And, you have the encoder decoder one, which is great. And even though you have the decoder only, there really still is an encoder. Um,
it seems these the people that make natural language processing models have a problem with natural language.
well, yeah. And we also have a penchant for cute names. So, I mean, if you look at like Google was naming them after Sesame Street characters for a while. So you had Bert, you had Bert, and then someone, did, I think there was Elmo and there's Ernie. And now they've got even more fun names. One of the more interesting things that have come out recently, it's called Platypus. Um, so my buddy and I actually have a joke that if we come out with our own language model, we're going to call it Snuffleupagus, just because it's a lot of fun for people to spell, right? But yeah, so
You'll definitely get a monopoly on Google rankings.
yeah, I guess. But yeah, so you have these different branches of models, and they're good at different things, right? So historically, and again, I'm going to say that there's caveats to all of this, but historically, your encoder-only models are going to be better at things like creating an embedding that you can use to do like a semantic search or some sort of like cosine similarity. Your encoder-decoder models are really good at things like translating, so like sequence to sequence. And then the decoder only models were historically like really good at like text generation. So, predicting that next word and doing it enough times to have something that was coherent. Um, Now, obviously, with the larger and larger models, the decoder only models have become far more capable. You can totally get yeah, you can totally get translation services with, Chat GPT. You say, hey, spit this out in French, it'll do it. Um, so it's, I mean, the landscape has shifted quite a bit. But
The lines are way more blurred.
and I've seen people use encoder decoder models to do, vectorization before. In fact, I think a T5 model was it was actually like at the top of one of the rankings for there's actually an embedding leaderboard, much like there's an open language model leaderboard. They're both hosted on Hugging Face. Um, so you don't always know exactly what's going to be best for your use case, but there's at least resources now that you can go and look at. So
My assumption was that, sorry, I went really quickly. My assumption was that an encoder and decoder model will be doing vectorization by default. So there's no, the intermediate vectorization is arbitrary, or not arbitrary, but
yeah, I mean, it would be by yeah. No, yeah, no, you're not incorrect. I think it just depends on what it is that you're trying to do. But like I said, historically the encoder only models have been better at creating like the embeddings than some of the other ones.
it seems like the lines of delineation is utility more than it is ability. It's like a specialized at that time relative to the power of these things, and then as things got a bit more powerful, then the lines weren't as necessary anymore because it could be sort of nested in one box. Now to the point where you could have that box be 4-bit sized.
Yeah. Well, and I mean, like anyone else in this space, I am still merely a student, right? And we're all still, yeah, every day is kind of different, right? So yeah, so it's the thing that's crazy is that you never know if you're going to wake up in the morning and now all of a sudden it's, oh, there's a new way to do, like, here's some non-auto-regressive model that's going to be better at, doing this thing than anything else that you could possibly throw at it. And so now you should learn about this and how to implement it and how to use it. And so, yeah, so that's, you never know. But like I said, historically, it was like, oh, you want to do text embeddings? Okay, I'm going to go grab like a BERT model or a longformer model or mini LM. Oh, you want to do like text generation? Well, let's look at like GPT-2 or, Bloom's was one that was out for a while before, it was one of the big ones out for a while. Or I want to use like Llama 2 or something, right? So, yeah, that's typically how it's gone. But at the same time, I wish I could create just like a fixed flow chart to be like, hey, you want to do this use case? Just follow these steps and here you go. You can kind of get close to that, but it's just changing so rapidly that sometimes it's challenging to adapt to it.
What are some of the things you think are interesting coming down the pipeline? That because you're the rare position that you're able to, in fact, have built something to digest some things. So what do you think that are some seminal papers? Seminal is a relative term, but that have come out.
So a lot of the stuff I've been looking at recently has been around the quantization, right? How do you be more efficient at training? How do you be more efficient at hosting? Because at the end of the day, I'm usually asked to actually deliver some kind of a solution for somebody to use. And so keeping costs low, making sure that we get the best performance. And then, obviously with pharma and I'm sure other enterprises, there's always some concerns about using like a commercial product that you don't completely have control of, right? So I don't know how OpenAI is going to version, GPT 3.5 or 4. And so that might have implications to what I want to do. And so that's why, like, oh, well, if I can host it myself in my own environment and I don't have any like privacy or security concerns, I want to do that. But I also don't want to have to go and go talk to like my boss's boss and be like, I need $10 million for compute.
Only 10 million.
Yeah, well, for for one thing or for, like a handful of things, right? I don't want to be doing that if I can avoid it. Or I don't want to have to say, well, for this project, we're going to need to have like an entire data center just in order to support it. So a lot of the stuff I've been really excited about has been like PEFT, which was a Hugging Face library. They have a paper. SPQR, which was a quantization technique. There was one that it's on my reading list.
What was the first one, and was it about the first one was quantization as well?
So PEFT. So PEFT is state-of-the-art parameter efficient fine tuning.
Okay, so it's just it's an optimization of parameters themselves, or just making it fine tuning it faster or something.
So yeah, so it was about how do you get more efficient at training these models, and so there's different approaches. There was LoRa, which is the low ranking adapters, which we kind of talked about. Prefix tuning, there's P tuning, there's prompt tuning, multitask prompt tuning. There's a whole host of different ways that one could go about it. And there's a library that's actually released called PEFT, which is this nice kind of one-stop shop where you can kind of, get access to some higher level methods, so you're not having to, spend a lot of time implementing things. I believe Hugging Face released that one. And then there's, another paper, well, it wouldn't be a paper, but another package that, goes along with PEFT is Bits and Bytes, which is Tim Demitter's. So he, I believe, was an author on the SPQR paper, but his research interests tend to be around this quantization, or how to be more efficient, around getting, imprints and training, and what do you like? How do you basically get it onto like a Raspberry Pi, or how do I start using it on a CPU instead of needing a GPU?
So are there techniques and optimizations that aren't really about just playing with the structure of chips, but some sort of like even mathematical, or like just some sort of some abstraction leveraging that can sort of shift things around a bit more efficiently?
Yeah, so like Bits and Bytes is definitely not about chip optimization or like rearranging a chip. It's all software, right? There's definitely organizations like, is it Cerebras? There's a couple of like smaller organizations that are kind of popping up that are trying to look into chips, right? Like how do I make a better chip for training a large language model?
But sorry, you said Bits and Bytes was they're the ones that did the 4-bit, right?
Yeah, Bits and Bytes is one. Yeah, but they're not doing it on a like changing the actual structure of a chip. It's all software.
It's all software. So they just made it so that what was in the chip was optimized for vector calculations, but they didn't actually play with the chip itself. So is there a layer above that where so what I mean is that and let me restructure my question. Is there something else going on or is there another abstraction where you're not having to, basically, is there something that's happening where you don't have to go down one level, because you can just use that on the lower level as well, but so it becomes a function, because there's a limit to, like, we know exactly what it is that makes it so we can do vector calculations more optimally. So we just go all the way down the stack till we get an electron to do that, a vector calculation or something, right? So that train of thought is feasible, is understandable, or to its own actual limit. But is there something like fundamental, where we can, like, maybe abuse the concept of computation for linear algebra calculations that someone's come up with?
So yeah, no, I hear what you're saying. Yeah, so that's actually a really interesting question, and the answer is I'm not certain, right? These are the things that like people are actively working on. And so like with kind of going back to Bits and Bytes, they went down to like, I guess, to I won't say like down to the hardware level. I don't believe that they went all the way down to the hardware level, but they did optimize some of the, like, because obviously they're not going to NVIDIA and saying, hey, you need to change the way that you're making your chip. But they are getting really close to it. And then PEFT would be kind of closer to what you were asking on, like, is there an abstraction where I'm not having to fiddle with something at like in C? So PEFT has a lot of higher level abstractions that integrate with like the Transformers library. So Hugging Face Transformers library, which is a very nice library for dealing with large language models, because you don't have to get into like crazy torch code. Like, it's a level of abstraction almost above like torch, right? So like PyTorch code, or Yeah, so you can get even higher, right? You can get to be like, I want to load my model, and you load the model, and I want to do yeah, and I want to like, maybe I'm going to strip the language modeling head off of this, and I'm just going to grab the underlying, representations of, the vectors. Or so it's a very powerful library. You can very rapidly implement, a language model like application, but you can also do a decent amount of experimentation instead of needing to, get super intimate with TensorFlow or PyTorch. It still helps to know it, but you at least have a slightly higher level of abstraction that you can kind of play around with, especially if you're like a researcher and you're like, I don't, if you're like a scientist, I would say. So like if you're like, maybe like you're a chemist, but you really wanted to be using a language model to do, something, um, it's going to be really good for you, because then maybe Python, but you don't know a ton about everything else. So you be able to kind of slot in and start utilizing it. Um, and it also works with a bunch of other things. Like I believe that they even have support for things like stable diffusion, and I think Whisper AI, which is a text, is it a speech to text model. So there's now becoming like, yeah. So they're kind of like adding a lot of different types of models that you can kind of use in their library. So it's becoming rapidly like a one-stop shop. They also have a very nice like a model repository and data set repository. But going back to your previous question, like other stuff that's really interesting that's coming out right now, um, this may sound really silly, but it's actually the data that you use to train, right? So if we think about like historically, like deep learning, um, so this kind of goes to one of my favorite interview questions. It's like, tell me an important truth that few people would agree with you on. It's a Peter Thiel question. My response to this is NVIDIA is bad for AI, which a lot of people would probably disagree with me on. And and I'll explain myself a little bit and why I think that this data. Yeah, right. Yeah, hopefully no one comes after me for that comment. But it goes back to like historically we're very interested in like how much compute can we throw at something, how big of parameters can we make it, and we were scaling that, and we weren't really thinking a lot on what is the data that we're putting into it, and is it enough? And there was a paper that I believe it was Google, it was called the Chinchilla paper, where they started like really focusing on the volume of the data, and does that volume translate to does it stop learning? Does it overfit? What's actually happening? Like, what's the optimal amount? And so we started realizing very quickly that we were undertraining a lot of our models. Um, and so one of the things that's been very interesting to me is seeing papers like the Platypus paper, which is it's Platypus: Quick, Cheap, and Powerful Refinement of Large Language Models, where they're getting like a subset of instruction tuned. Well, they have like a llama model, right? A base model. And then they're taking like 25,000 examples and they're applying that to a language model. And then all of a sudden it's shooting up to the top of the performance, and potentially rivaling other, commercial applications or commercial large language models. And so to me, I think that's really fascinating, because that tells me it's not necessarily always about the volume, but also like what types of content do you put into these models to get certain types of behavior? Because one of the things that was interesting is their curated data set is they're actually using cosine similarity to determine, or basically to try to optimize for, well, not quality, difference. So they were looking at, yeah, trying to get a large variety, as opposed to like if you had 100,000 samples and let's say 50,000 of them are very similar in the way that they're asking a question or giving a response. That may not be. I think that was kind of the hypothesis, is that might not be as good as having 50,000 samples that are very different, but have a but yeah, but just having that variety of different tasks. So this data set that was released, it's just a curation of already existing data sets. So they have like Science QA and Theorem QA and Open Book QA, and like they had SciBench and some others. And they basically tried to curate this, this set of samples and say, okay, and if you have a similarity above a certain threshold, we're going to just, we're going to get rid of one of those samples, and then we're just going to keep compiling it. So they get this data set of, like around 25,000 samples, and it's the number one right now on Hugging Face's OpenLLM leaderboard. So they took a 70 billion parameter Llama 2 model, fine-tuned it on this data, and then it's like number one. The other thing that was interesting, and I believe it's coming from the same lab, and I believe it's slightly touched on, is that they're finding that you can merge different LoRa's, so those different adapters. So you could train, this was done with like Stable Diffusion. Are you familiar with Stable Diffusion? Okay. So this was done with Stable Diffusion, where you could have like an adapter for like Pokemon, and then maybe you have an adapter for like selfies. And so now you can have like Pikachu taking a selfie. And so we found that also is, you're able to do that with like large language models. And there's research that's starting to show that it might matter in what order you put these adapters on the model, which is also, yeah, like to merge the adapters into the model. So you like merge one adapter, then you merge another, then you merge a third.
Okay. So precedence has meaning, which also is self-evident by the sentence, I guess, in a way.
Right. And so that's one of the things that that's been really kind of interesting to start seeing, is that, that work. And I personally am going to be starting a ablation study on basically the platypus data set. One of the things that I want to do, and this will be my own personal time, but one of the things that I want to do is start looking at, well, what if I remove like this type of data from the data set? What does that then cause the model to do? Like, where does it start suffering? Obviously it'll be a very expensive ablation study, but I want to like, there's some data in there that's considered non-commercial license. So that means you can't use platypus for commercial uses. I can't use it at work, right? So what if I take all of that non-commercial data out, and then I train the model? How's it gonna perform? What's gonna be different? And then what was special about that data that got it to the performance that it was achieving? And so those are the things that I find like really fascinating right now. And there's like, again, this isn't even doing the field justice, because there's so much that's going on. They've got folks working on like multimodal, which is like, images, or even like maybe you have just different types of media that you want this model to consume. You've got folks working on how do I, looking at like synthetic data sets, how do I generate synthetic data sets and train my models? I find that one a little interesting. There was research showing that'll probably go badly.
Yeah, it seems to degenerate the quality of the outcomes, but that might also be the inverse proof for why the cosine similarity, where the distance is highest for data sets that have been trained for diversity, is actually working. So they might actually prove each other out, right? Because they're basically inverses. Yeah, they're inverses of each other, or opposite. I guess in English they're opposites.
Yeah, and then the alignment is another big one right now. Is how do you train out biases? How do you get it to not say something offensive, or to, how do you differentiate between, this is actually a slightly funny story. At work, we actually ran into an alignment problem where we asked a question about something in chemistry or something like medically related, and the model, it was a commercial model, and it came back and it's like, as an AI language model, I can't give you that answer. And I was just like, okay, but we're like, this is like a legitimate use case. That we worked with the folks, and we got it fixed, but it was one of those, like that's an alignment problem. How do you, like when you have a model and you're giving it to somebody, you want to make sure that like someone's not going to go use it to build bombs, or to, go be toxic on the internet or whatever. But at the same time, when you need it to work in a certain way, you got to be able to get it to work in a certain way. So how do you deal with all of that? So there's research into that as well.
And what is the bottom line lock for that, right? Like, and what is levels of security? Like how many locks for the bomb making versus how many locks for um, sort of inappropriate language use?
Right. And how do you make sure you can't defeat it? So that there was an interesting there was an interesting paper that came out. That they used like a shift cipher to like ask like how to like hotwire a car or something, like to do something that would be picked up on like an alignment filter and filtered out. And it was funny because the filter didn't find it, but and the language model figured out what they were still saying, even though it looked like gibberish, and then responded in, I think, a cipher response, which they were able to convert back into English. So like the cybersecurity, or I guess just the overall security of the language model as well, is another big spot of interest.
So if I'm getting it right, they wanted to bypass it, and they used a cipher for it to decode, for it to understand and recode, so that they could decode, and that's how they bypassed it.
Yeah, apparently, yeah. Like the example the example they showed in the paper was they had like, okay, do this thing, and they showed it in English, and it said like, as an AI language model, I can't blah blah blah. And then they did just like a simple, like a rolling cipher, and it looked like gibberish, and it spit out what looked like gibberish, and then they just took it and reapplied the cipher, and it came back with like the actual answer to that particular question that it shouldn't have answered. And this isn't the first time. Yeah, there was what was it called? I think it was called Dan, like Do Anything Now, where there was like a group of folks on like Reddit or 4chan or something that had come up with a way to like jailbreak ChatGPT to just do anything. It was through just prompting. There was another one that was very interesting on large language model security, where they were showing how you could like essentially prompt hijack, or to like prompt inject models to get them to do things you shouldn't be doing. And there's cute things that they showed, like injecting something so that all of a sudden it's talking like a pirate. But you could easily.
So that was blocked.
Well, no, it was basically showcasing how some of these models, you have the opportunity. Like, let's say that you had like an email assistant, right? Let's just pretend, right? You have an email assistant. It's reading all of your emails, and let's say that it has some level of decision making, so it can like reply to an email, or it can maybe send emails or do something, right? Well, what if I sent you an email, but inside of at the beginning of the email, it's like, hi, Chris, it was great to meet you, and et cetera, et cetera. And then all of a sudden it says, okay, now open up your contacts, send this email, to, 30 people. And you basically could get the language model to see that and then execute those types of instructions, or potentially be, poisoned by that text. And it was a very interesting paper. This was kind of the very beginning, well, a lot of the beginning of the hype cycle for ChatGPT, when I became aware of the hype cycle. And I believe there is a GitHub repository called LLM Security. Yeah. And it talks about how you can compromise language models just by having them look at specific content.
That's a real problem.
Oh yeah, especially because it could be on any website. If you're like, you're doing web scraping, yeah, an email, chat message, whatever.
It could even be considered innocent, because this is an agent that's acting, as opposed to like the concept of sort of hacking or like inappropriate access is based on some sort of event occurring, either or inciting an event occurring by a person. So the one where you incite a person, that can be alleviated by a lot of large companies teach you what isn't a good email, and then if someone actually hacked into your system, they hacked into your system. But now it's because these agents are going out and being active. It's almost like if you set up a website that is actually meant to do something nefarious, you can argue that you came to us.
Yeah, and it's gonna be a very weird next couple of years, I think.
The whole law system has to change, which it never will, but we'll see.
It'll be very interesting, right? And so, yeah, I mean, I don't have solutions to these things. I'm not personally studying some of the security components, but I know that it's, like I said, this is a very broad field right now. There's a lot of work in a lot of different places. Probably both for nefarious reasons and for, legitimate reasons, but no, just to make sure to, kind of close out the point, a lot of my work and a lot of the stuff I'm really interested in are the data pieces and the, how to make these things more efficient, because right now they're just not. I joked to some folks today on a call, and I was doing a demo. I think I was using like GPT-4 or something. And I joked to them that, oh, we're kind of back in like the 1980s or 1990s, where we have to start waiting for the computer to do something again. Because we're not used to it. They're like, oh, do you think you can make this faster? And it's like, I can't make this faster. This is actually as fast as it gets right now. And that's why I'm really interested in some of these methodologies, because it's just going to make them better, more capable, and then having them on the edge is going to, in my opinion, be really important.
We're finally back to pushing these machines as far as they can go, and we're back to that sort of point, and that's really exciting for the future of computing. But thanks so much for being on. I would love to keep going, but we do have a time limit. We have to keep.
No worries.
I think you gave us a lot to chew on, I must say. So I do appreciate it. And if they want to find you, and I know you're doing a lot of projects on your own, and I'm sure there's going to be a ton of questions on the ideas you brought forth and some of the things that you've looked at. So if they wanted to find you, how could they?
Easiest would be LinkedIn. I'm not, I'll be honest, I'm not super active on social media. When you reached out to me, I think it took me like a couple of days to like get to you, because I had no idea, because I don't check it. I actually got lucky.
You're a real person.
Well, yeah, I got lucky because one of my, we had an intern, and they're like, can I connect with you on LinkedIn? And I was like, yeah, sure. And then I looked, I was like, oh, somebody, like, I've got a bunch of missed alerts, but LinkedIn is probably the best way to get in touch with me.
All right.
And again, I want to emphasize, I am not the master of the universe at this stuff. I'm learning just like everybody else. But it's super exciting, and right now it's really cool because just about anyone can participate. So I hope that folks, get excited and try to participate. Anyone with a laptop nowadays can do this. You don't need a data center, which is great.
Just great. Thank you so much, Christian. I appreciate it.
Yeah, thank you. It was wonderful. Have a great day.
If you like what you saw, take a look at the description. You'll see segments. You'll see the full podcast. Go take a look. Please go listen. Don't forget to like and subscribe. Thank you for watching. We'll see you later.